Okay, so today we are looking at ionic bonding. So yeah, what is an ion? Dot cross diagrams to show ionic bonding, and then the properties of the giant ionic compounds. And if you haven't done so already, pause the video and download this copy of the PDF. The link is in the description so you can be making your own revision notes as we go through. So let's get started. So types of ion. So here are some definitions straight from the textbook. So what is an ion? So an ion is a charged particle made from an atom or group of atoms formed by the loss or gain of electrons. So it's anything with a charge can be called an ion. So you could just have an atom, or as we'll see later in the topic, you can get compound ions as well. And then we've got two names of our ions. So an ion is anything with a charge, but then a cation is a special name given to something which is a positive ion, and positive ions are always formed by the loss of electrons. And then anions are a special name given to negative ions, and these are always formed by the gain of electrons. So there we go. So what we're going to be looking at with ionic bonding is how cations and anions are formed, and then because of that they then bond together. So before that, we have an example to show how a cation and an anion is formed. So here we have how a cation is formed. So we're using sodium as an example. So this is sodium's electronic structure. So it has 11 electrons, and if you can remember from the last video, this is where they all go. And yes, sodium loses one electron. So if we can also remember, all the atoms are trying to get a full outer shell. So it loses one electron because it's easier to lose one electron than it is to gain 7 electrons. So once it's lost this electron, this shell is now empty, so we can get rid of that. So now its outer shell is full. So it has a full outer shell, happy days. And because it's lost an electron, it now has a positive charge. So where has that positive charge come from? So we have 11 positive protons in the nucleus. We now have 10 negative electrons. So overall it has a +1 charge. So this is where the charges come from. And as it's got a charge, everything with a charge, so all the ions always live in a bracket, and then you put the charge on the outside of the bracket. So there we go. So that's how a cation is formed, through the loss of electrons. Now let's look at how an anion could be formed by the gain of electrons. So here we have our old friend chlorine. So chlorine with its 17 electrons. So this is how they get filled. But same as before, it doesn't have a full outer shell. So we're kind of missing an electron over here. So what can chlorine do? Well, chlorine could lose its 7 electrons, and then it would have a full outer shell, but it's a lot easier to gain 1 electron. So that is what has happened. So chlorine has gained 1 electron, and it is now therefore now got a negative charge. So where has that negative charge come from? So let's calculate that. So chlorine has 17 positive protons. It now has 18 negative electrons. So overall, that is -1. And same as before. As it has a charge, everything with a charge lives in a bracket, and then we write the charge on the outside. So there we go. So this is how the ions are formed. So now let's look at ionic bonding. So to show bonding, we use these things called dot cross diagrams. Dot cross diagrams, and this is just showing where the electrons are moving around. And these diagrams all kind of have the same generic outline, but we're going to fill it up now using sodium chloride as an example. So so sodium chloride is a salt. It is an ionic compound. And so what is going on? So sodium has lost its electron. That electron doesn't disappear. That electron goes to another element, and in this case, it's going to chlorine. So if we just go back over here, so this electron, it can't just disappear. Things can't disappear, and chlorine can't just gain an electron from nowhere. So what is happening is this electron is heading over to chlorine. So we don't need to draw all of this, but what we do need to do is be able to draw these dot cross diagrams. So what is going on? So this is sodium and this is chlorine, and all we need to show is the outer electron. So we don't need to show all of the inner shells, we just need to show the outer electron. So this is why these diagrams are nice and simple and pretty straightforward once you get the hang of it. So let's get some electrons drawn in. So sodium has 8 electrons and we're drawing these as dots, and then for chlorine we have to draw crosses. So chlorine did have 7 electrons in its outer shell, and then we've got the dot to show that that electron, that bonus electron, has come from sodium, and then we're going to add in the charges. So we have sodium is positive and chlorine is negative. And then because of this, because of the positive and the negative, they form a very strong electrostatic attraction, and that's what is bonding our ions in place. So this is why it's called ionic bonding, because it's ions that are bonded together. So more on that later, but let's look at a few more examples. So here we have, so magnesium, and this is magnesium's electronic configuration. And again, it wants to have a full outer shell. How is it going to do that? It's going to lose those 2 outer shell electrons, and we end up with something like this. And now we have a +2 charge because it has lost 2 electrons. Then magnesium can bond to oxygen, and then so it loses those 2 electrons. They're going to oxygen. So here is oxygen's electronic configuration. And we can see here it needs 2 electrons, so it's easier for oxygen to gain 2 than it's to lose 2. It's gained those 2 from magnesium, and it has formed a 2 negative charge because of that. So let's draw out our diagram. So same as before, we don't need to draw the inner shell electrons. So we've got magnesium, and magnesium now has a full outer shell because it's lost 2 electrons. We have got oxygen. So oxygen has 6 outer shell electrons because it's in group 6, and it has gained 2 electrons from magnesium. So let's put the charges in. Oh, that's a plus, and this is a minus. So there we go, nice and straightforward. And the other key thing is that the total positive has to balance with the total negative. So these are the same, so that balances out, cancels out. So this works, same as before over here. It's +1, -1, so everything works, and this is how we're getting our formula. So this is why we've got NaCl. This is why our formula for magnesium chloride is MgO. But let's look at one trickier example where they're not in a 1-to-1 ratio. So we're not going to do all of the diagrams as before, but we can hopefully just accept and trust me that so aluminium is in group 3, so aluminium loses 3 electrons, so it ends up with a +3 charge. Chlorine we've already looked at, and chlorine gains 1 electron to form a -1 anion. So these charges don't balance out, but what can we do? Well, we can have lots of one element to make sure everything balances out. So what we've got is we've got 1 aluminium that is 3+, and this is balanced with 3 chlorines, which are all negative by 1, but overall we've got a total charge of -3 to balance out the +3 charge. So this formula is AlCl3. There we go. But more on formulas as we go through the topic. But this is why we start to get the little numbers over here. Okay, then doing the dot cross diagram, so getting everything all filled out. So this is now full. And so aluminium has lost 3 electrons, and they are going to chlorine, so 1 electron per chlorine, and then chlorine in group 7 has 7 electrons. So there we go. Happy days. All right, so there we go. So that is ionic bonding, and then here is our definition. So an ionic bond is a strong electrostatic attraction between the ions, so it's between the other positive ions and then negative ions. Yeah, how can we tell if something is ionically bonded or not? Just by looking at a formula. So this is always between a metal and a non-metal. So metals always form cations, and non-metals pretty much always form anions. So yeah, the metal loses electrons and the non-metal gains those electrons. So yeah, we've got metal and a non-metal. We've got a metal and a non-metal. And finally, we've got a metal and also a non-metal. Okay, so on to our final thing. So yeah, so the properties of the giant ionic compounds. So the giant ionic compounds have their properties because of the bonding. So bonding is always linked to their properties. But first of all, let's break down these words a little bit. So giant just means big. So ionic is, yeah, because it's the ionic bonding. And then, yeah, compounds, because it's between two or more, yeah, different elements. So what do we have up first of all? So here we have a AI image, and I think it's done a pretty good job. So everything is arranged regularly. So yeah, so giant ionic compounds, yeah, form a giant ionic lattice. So lattice is just a fancy way of saying repeating pattern. So maybe the colors aren't particularly great, but we are seeing a repeating pattern. And yeah, this is what we've got over here. So you should be able to draw a diagram like this. So yeah, we've got alternating positives to the negatives. So there we go. Nice and straightforward. And yeah, it's nice and neat, yeah, neatly arranged. As yeah, it is a lattice, so it's not random ions everywhere. So yeah, so this is our giant ionic lattice. So yeah, ionic bonding gives us our giant ionic lattice. So yeah, it's not just two atoms bonded together, but it's millions and millions and millions. And yeah, they form this very regular structure. So what properties are we getting? So because we've got this very big structure, we have some certain properties, and we need to know these three things. So the first thing is, here is a thermometer, of course. And because of the giant ionic lattice and the really strong electrostatic attraction between the ions, they have a very high melting and boiling point. So the melting and boiling point is very high because it requires a lot of energy to rip those ions apart, to separate out those ions. So yeah, so the melting and boiling point is very high. What is our next property? Well, our next property is that they are soluble in water. So our ionic compounds, they dissolve in water. Water is actually able to break up the lattice. So yeah, the majority of them are, yeah, soluble in water to give you a solution. And the final thing is, yeah, they conduct electricity, but they don't conduct electricity all the time. They conduct electricity when they are a liquid or when they are dissolved in water. So yeah, so for electricity to happen, you need to have an ion, you need to have something that can carry a charge, and that needs to be able to move around. So when they're in their solid form, the ions are fixed in position, so they can't conduct electricity. But when you turn it into a liquid, the ions are free to move around. And when they are in a solution, again, the ions are free to move around. So this is why, yeah, they can conduct electricity when they are in a liquid or in solution form. So there we go. So those are the three main properties that you need to know about. And yeah, there we are. That is everything from today. So thank you for watching. And as always, tell all of your chemistry friends. The more people know about these videos, the more that will get made. All right, I'll catch you in the next one. Bye.